Hello, Shasta High School, Honors Math 1. This is Mr. Roberts, and I'm going to go through the Chapter 6 study team test. Um, the Please use whatever parts or none of the parts of this video that you want. I am intending to be thorough, and my ideal audience is kind of a student who might be like missing some things. So I want to try and be thorough. If you've got questions or there's things you're wondering about, please come by and talk to me. So here's the situation in question 1. It says I'm asked to find the equation of a line that has two properties. One of the things is it has to go through this point, and the other thing that's true is it has to be perpendicular to a particular line. So if you kind of just think about this, right? So here's the thing. Let's say that I'm over at negative 6, 5. Here's this point that we're talking about. And I don't know what this line is. We're going to look at that. But let's say, for example, this line was like this, right? Well, I know that I need to be finding the line that will make a perfect right angle with this line, right? So this is the line. This would be the line that I'm trying to find, right? So it has two properties. It goes through a particular point, and it's perpendicular. It makes a right angle with another line that's described in this problem. So the first thing I need to know that I do know is that if lines are perpendicular, their slopes have a special relationship, right? We've looked at it. If I rotate a line through the plane 90 degrees, basically the x and y's change the rise and runs change places. We've seen that demonstrated in class, and the sign changes from positive to negative. And we summarize that by just saying the slopes are opposite and reciprocals. So let's look at this line, right? What is the slope of this line that I'm given? And then we can talk about what the slope would have to be if it's perpendicular to this line. So this line has a slope, and you can see that there's 2 points that are given. There's an xy and there's an xy. And my slope is the change in my y's divided by the change in x. So I'm just going to go ahead and look at this in this order. I'm going to say 12 minus 8. That's the change in my y values. And I'm being very specific. I'm taking, in this case, the y on the right, and I'm subtracting the one on the left. So I'm going 12 minus this 8. And I'm going to do the same thing for the change in my x. I'm going to look at same order, 7 minus 5. 12 minus 8 is, of course, 4. And 7 minus 5 is 2. So I'm looking, this line that I have, this line, the line that goes through these 2 points, has a slope that equals 2. Well, that's not the line that I want. I want the line that has a slope that's perpendicular to this line. So the slope that I need is not 2, but I need the slope of negative and then the reciprocal 1/2. So if you look at it, I have two things here. I have a point and I have a slope. And I need to find the equation of the line with that goes through that point and has that particular slope of negative 1/2. So two ways I want to do this. One of them is, I think, easier. We discussed it just briefly in class, and we're going to be working with it more. And one of them is the way that we've been doing since the very beginning, right? So we know the equation of any line is y equals mx and then plus b. And the goal here is to figure out what b is, this y-intercept. I don't know it. So I can do this. My approach is to use the point that I'm given, right? There's an x and there's a y value in the point that I'm given. Plug those in and plug the slope in and then solve for b. So we know that y is 5. We know that our slope is negative 1/2. We know that x is negative 6. And then we've got the plus b. So simplifying this, we're looking at 5 equals, this would be a positive 3 plus b, and if I subtract 3 from both sides, I can see that my y-intercept, b, is 2. So now I know the two things that I need in order to write the equation of this line. And of course, those two things are the slope parameter and the y-intercept parameter. So I can just very simply write the equation of this line, and I'll do it right here on my answer line. Y equals, the slope was negative 1/2 times x, and my y-intercept was plus 2. So before I leave this problem, I want to look at this in terms of the point slope formula. And for the point slope formula, we're looking at this this general rule form y minus the y value that I'm given for a particular point, and that equals the slope times the quantity of x minus the x value that I'm given for a particular point. So this is pretty easy. I don't actually have to solve for b. I just have to plug in what I know. So this would look like this. It would be y and then minus 5 equals my slope, which was negative 1/2, and then times the quantity of x. And in this case, it's going to be minus negative 6, so I just write plus 6. So this is the same line, right? But I've just plugged things in using this point slope form. And one of the things that always kind of I was curious about as a student myself was, are these really equivalent to each other? And it's not difficult to see that they are. We can just basically change the form of this a little bit. So for example, I could add 5 to both sides. So I would get that y is equal to this negative 1/2 times x plus 6. And then now I'm going to have a positive 5. And I'm going to go ahead and distribute the 1/2. So I've got y equals negative 1/2 x and then minus 3 and then plus the 5. And you can see when I simplify it, I do get y equals negative 1/2 x and then plus 2. So it is indeed exactly the same line, right? But this point slope form makes it kind of easy to plug in, because all I need to do is give it two things. I need to get, well, actually 3. I need to give it the y value from the point that I know. I need to give it the x value from the point that I know. And notice that subtraction is part of the formula, so that's already going to be subtraction. And that's why this, in this case, when I was subtracting, the negative 6 ended up being a positive 6 here. And then I just also need to plug in the slope that I know. So that's just an aside, something to think about. We'll be discussing that more, but same problem, two different ways.